All right, guys, I want to talk about Charles' law, and it's about temperature and volume at constant pressure. So right now we're just talking about temp and volume. We're not talking about pressure. I want you to imagine a balloon. I'm going to make mine a hot air balloon, but it doesn't really matter what kind of balloon, okay? I have a hot air balloon, and this hot air balloon is at low temp, okay? As I increase temperature, even if I keep the amount of gas within the balloon the same, I'm not adding any additional molecules, my balloon is actually going to inflate. And why is that? At low temperature, let's go back to kinetic molecular theory, okay? Low temperature equals low kinetic energy. Those particles in this balloon are moving quite slowly, okay? So they're not exerting very much force into the sides of their container. However, as I increase the temperature, my molecules have so much more energy. They are moving so much faster. They're going to hit the sides of the container harder, and at constant pressure, that means they're going to inflate that balloon, okay? So at high temperature, we have high volume. So this means that temperature and volume are directly related, and your textbook relates that as V1 over T1 equals V2 over T2. So what that means is, if I increase volume, so I go from T1 to T2, and T2 is higher, V2 also has to be higher. The ratio between those two has to remain constant, right? I don't particularly love this arrangement of that equation. I prefer to, to get rid of the fraction, okay? And to do that, you would say V1 T2 equals V2 T1. In all cases where you have gas law problems, you're just missing one portion, one variable in your equation. So usually it's one of the twos. So you might have initial volume, initial temperature, but you might not have final temperature. So you'd have to solve for T2. If you were doing that, you would just divide both sides of the equation by V1. So T2 equals V2 T1 over V1. Okay, so you're always going to be solving for one variable within this equation. If I were you, I would definitely have Charles's law, and I would really, really want this equation written down in my notes somewhere. Hopefully soon we will be able to work problems with this, so hang on to that.